Today we have a Ford Focus with a 2-liter engine, petrol engine. The problem with the car is just the check engine light coming on, just intermittent. It's not all the time there, but it does come on occasionally. That's what the customers have told me. A little bit of history on that. Last time the customer was in, I quickly erased the fault code because we didn't have much time and the customer didn't have time either. So back then, if my memory serves me right, it was something to do with the EGR fault. So I just cleared the fault code, and since then the customers come back again and told me that engine light has been coming on and off. So we're gonna diagnose this car today. I'll just give you the. I have my scan tool hooked up already. Just using my OTel. We're quickly gonna start the car and see if the engine light's staying on or not. Yeah, looks like we don't have a engine light at the moment. We'll just go into the computer and see if we can find any fault codes there. Alright, we got a EGR system fault malfunction P0400. So it's the same fault code as the last time. System floor malfunction. Okay, so sometimes when you have fault codes, you really have to take care of the description on the fault code as well. Right on this one here, you see the EGR circulation system flow malfunction. So it's talking about the flow rates, the flow of the EGR gas. So I think it's a performance based fault code. If you have, let's say, a circuit fault, wiring problem, or EGR valve itself, or the pressure sensor, the position sensor on the EGR, all that circuit related problems, you usually see a circuit related fault. And what can happen is those type of fault codes takes a very long time. Those type of fault code, circuit fault codes, will come back immediately, but this type of fault code with the system flow malfunction is a performance type fault. They take time because the computer has to go through its checking, monitoring system, and then the fault code will come back. So according to customer, the engine light didn't come back on for a few days, then it came back on, then it went off. So according to the customer, definitely it matches our fault code. It's a performance type fault code. So if it's a circuit type fault code, as soon as you turn the key off and on, or sometimes just start the car and as soon as the computer start activating the EGR system, you'll see that fault code pretty much straight away. But this type of fault codes is really hard to diagnose sometimes, and you have to be really careful what parts, what system you're checking when you diagnose this car. I'll talk about this a little bit more a bit later. I'll probably take you on the whiteboard, and I'll try to show you as much as I can and as much as I know. So performance fault code. Okay, let's go back to our maybe wipe data, and we just see what's the live data, all the data's doing. I don't know what I'm gonna look for at this stage, but what we can do is we can start the car now and just let the car warm up. Sometimes, yeah, EGR system doesn't work when the car is cold, so let that engine warm up a little bit as we are scrolling through this data here. If I can find it, might go desired idle speed as well. Alright, we just look at these data here. Now I'm just gonna rev the engine a little bit and see if this EGR position desire changes or not. Yeah, it does change. It does change. Not too much. All I'm looking at this one here. It does change the desired EGR, but it's not changing a lot. It's only sitting 2-3%, something like that. I'm pretty sure it's a percentage, but it's only showing me 2. I'll just wait and watch. Maybe the temperature hasn't reached its operating temperature yet, so maybe that's why the computer is not commanding that EGR motor as much as I like to see. So we probably just we probably just get the coolant temperature sensor as well here. Engine coolant temperature, we throw that in there too. So we're sitting about 81 degrees Celsius. Just let that warm up a little bit. As you can see up here, now we can see some activity on the EGR motor position desired. That one just jumped up to 26, the EGR motor desire. So it's definitely reacting to the rev change, the EGR position sensor. I know, just judging by the fault code, I know the EGR valve electronically should be working because we don't have the fault code, but mechanically the valve could be stuck and might not be functioning physically. I don't know that just yet, but judging by the fault code description, I definitely think the EGR valve is good electronically. I'll just put that away for now. And just on this idle speed, if you look up here on desired idle and engine idle, it is not it's not same. So the engine computer wants to see 736 RPM at idle, but the idle actual idle is 817, 820, 30, just jumping up and down. So definitely the idle is a little bit higher than what the engine wants to see, computer wants to see. Our long-term fuel trim, our short-term fuel trim looking pretty good. Manifold absolute pressure is sitting about 41 kPa. Let's maybe right here we can go there and see if we can change that to a different manifold absolute pressure. That's PSI. That's kPa. We only got PSI and kPa. Let's go psi. So we got about 6 psi of pressure there in the intake manifold, which is looking a little bit low, but I'm alright with that value just at this stage. Just these two, I don't like it. Just the engine RPM, and these are versus your actual engine RPM. Definitely the engine is running a bit. The revolution of the engine is a little bit higher than what the computer desires. Definitely, that's one problem I see, and also on your manifold pressure sensor, I'm seeing a little bit low value there on the vacuum. I want to probably see a little bit more vacuum in this engine. So,
alright, I just want to quickly talk about this before we move forward on this video. This will show you how to calculate engine intake manifold vacuum. Okay, just bring that up. So basically, when we're looking at the scan tool, let's say this one has 6 psi of intake absolute pressure sensor reading. So if you want to do a calculation for how much vacuum the intake has, you can't simply just go into Google. Let's say we're gonna do intake manifold. Let's just go PSI to inch of mercury. Right, you can't just put 6 and it will show you 12 inch of vacuum. You can't do this because this is not right. So you need to do a little bit of calculation in order to get the right vacuum reading for your intake manifold. So in order for that, we need to quickly know the basics. So there are obviously 14.7 psi or 100 kPa of atmospheric pressure in our environment, in our air. So that's all the time there. Now the reading can go up or down by a little bit depending where you're from, depending on the altitude and all that. But 14.7 and 100 is pretty standard number. Now we need to take that into consideration when we doing a vacuum for the manifold calculation. Now there's 2 ways you can do the pressure reading. Okay, now one's a gauge pressure. So what is a gauge pressure? So just for example, when you put the manifold vacuum gauge, like just a little analog gauge and hose onto your intake manifold, you're gonna read gauge pressure. So what that means is the gauge has already been calibrated and taken this 14.7 psi into consideration. So what that means is it's going to start at 0 psi or 0 inch of vacuum when the engine is switched off, when there is no vacuum. But we know, because atmosphere has 14.7 psi, so if this gauge pressure was true pressure reading, we should be seeing 14.7 psi, not 0 psi. So that is the reason why when we looking at the scan tool data and you see 6 psi here on this engine we're working on today, it is not gonna be accurate, okay, because this is absolute pressure. So now let's go back to my little notebook here. So we know now what is a gauge pressure. Now there's absolute pressure. So see, it's in the description, manifold absolute pressure. So you need to remember this pressure sensor reads absolute pressure. And what is absolute pressure? Absolute pressure is a real pressure. What it is, it's going to read. So when the engine is turned off, if you look on the scan tool, obviously ignition key on, look on the scan tool, the pressure reading on the manifold absolute pressure will be 14.7, somewhere around there, reading with the engine turned off. Now, to really calculate the vacuum through our manifold pressure sensor, what we need to do is we need to so let's take an example of this known good data from the 2007 Ford Focus, same engine. We see here absolute pressure. Sensor up here is 27 kPa. 27 kPa, you can do a conversion on a Google if you want to use Google. 27 kPa is 3.91 psi. Okay, so what you need to do here before you can calculate this vacuum is you need to subtract 3.91 psi from 14.7 psi. So anything under 40.7 psi is a vacuum for absolute pressure measurement. Okay, so you subtract that with 3.91 psi, and we got the sum of 10.79 psi. Now 10.79 psi is a 22-inch of vacuum. If you go onto the Google, you put that 10.7, it was 7.5, I think 7.9, 10.79, you see the vacuum is about 22 inch of vacuum here in this known good engine data. Now the car we're working on today has a vacuum of 6 psi. Now we go back there again, and 6 psi, we're going to have to do the same math again. So we got a minus 6 psi from 14.7 psi, which is your atmospheric pressure again, and the balance is 8.7 psi. Now you can do the 8.7 psi conversion on Google again. I've already done it, which is 17.7 inch of vacuum. So that's what's present in our car that we're working on today. So that is why I said this vacuum looks a little bit low on this engine, or the pressure looks a little bit high compared to non-good. This one's got a 27 kPa. This one had, I think, 41 or 42 kPa, and I changed the my measurement to psi, which is 6.9. So that's how I come to the conclusion straight away that this engine has a low vacuum in the system.
So basically I was looking at this desired engine speed and the actual engine speed, and the RPM was a little bit higher than what the desired engine speed. So definitely something's going on there. Also your manifold vacuum was a little bit lower than I thought I want to see, but our fuel trim looked okay, because what I'm trying to get at is we may have a vacuum leak, air leak. That's what I'm trying to get at this stage, looking and judging by them data. But definitely our short-term, long-term fuel trim, the vacuum leak wasn't showing up like I would say you're gonna see positive fuel trims there, but we weren't seeing that. But definitely the revs and the manifold pressure is definitely definitely pointing me towards a vacuum leak on this engine. Now I'm just going to quickly talk about the vacuum leak. A lot of the cars, especially with the new electronic EGR valves, the vacuum leak can give you trouble codes on EGR, especially on GM and a lot of the Ford I've seen mainly. I don't know if this will work with every other cars, I don't think so, but I know Ford and GM cars do throw a fault code for EGR if there's a vacuum leak, just with my experience. And I probably will show you on the board what I'm talking about. But before that, I want to just quickly do maybe a smoke test in the intake and see what we get there. I've got my smoke machine set up there. We're just gonna put some smoke in this intake. We'll just wait for the smoke to come out of, if there's a leak, obviously it will come out. I can already see the smoke coming out of the exhaust, intake there, if you can see here. I don't know if the camera is picking up or not. I'm just looking for that leak. It's a very big leak, actually. I can even hear it. Okay, if you can see there, the smoke coming out of there, you can see right there, right in there's something there. I can't really tell what it is. There's a lot of smoke coming out. It's really hard to see, especially on the camera, but looks like a little pipe in there. I'll just turn that smoke machine off real quick. You can definitely see that. Right in there. If you can see, there's a hose that runs under that manifold. You can see, I hope. Yeah, it's really hard to see. There's not much space there, but looks like, yeah, that's a PCV valve actually. Yeah, looks like the little hose that runs from PCV valve to the intake manifold's got a big split on it, so that's where all the smoke is leaking. Now this one will definitely cause a EGR problem. It will definitely throw a fault code for EGR, that's for sure, and I will explain to you on the board why it does that and how it does that.
Alright guys, there's just a little bit of a extra information on this problem we are dealing with. Like I said earlier, I'm gonna discuss a little bit more about this on the whiteboard, but I'm just gonna use my laptop to record everything here. So let's start with the PCV valve. So right here we got PCV valve that sits right underneath the intake manifold. Okay, now it's really hard to see, as we saw on the video before. It's really hard to see, but this is what you'll see if you pull that intake manifold out, PCV valves onto the block, and there's a hose like this will connect to this PCV valve, and this other end will connect to the intake manifold. Right, so split we had was right in this area, right around here. There is a large vacuum leak was happening. So basically, to fix this problem, we're gonna have to change this hose. So yeah, that's where the problem was. Now, I just want to talk a bit more about how I think this is gonna fix our EGR problem. Now, there could be other problems too on this EGR system, but sometimes you just have to do as much as you could, because we didn't have time, a lot of time to do all the diagnostic, all the procedure for a full system check. And plus, sometimes it also depends on how much money a customer wants to spend diagnosing the problem. Now, to really diagnose this problem fully, what we need to do is we needed to check if the EGR valve is physically opening and closing or not. We need to see controls and power supply and all that on the EGR valve, to make sure the EGR valve is okay electronically. Also, even if the electronic is good, we could have a physical valve broken or seizing up, or carbon buildup. It can happen too. So this is just the other side of this valve. If you look on the engine, you'll see like something like this on the outside, and you'll see something like this if you pull it out on the inside. So there's two ports here. So how this works on this engine is basically, let me see if I can find another picture here. So basically, this is the head, just on the rear of the engine. So on the head itself, they have a design where the exhaust comes through within the head and goes through the EGR valve. EGR valve usually bolts up here somewhere, and through the EGR valve it goes through this another hole here, and it is also got a hole right way through into the intake manifold area. So basically it's done all within the head itself. So there is no plumbing, there is no hose or pipes going around on the engine. So just something to look for here is you can't just take the hose or the pipe off and physically see if it's blocked or not. Okay, for this one, you're gonna have to, if you're gonna go and visually want to inspect everything, you're gonna have to pull the EGR valve out, maybe stick a camera in there, and stick the camera in there and see if you can see any blockades, carbon buildup, anything like that. Also, if you take the intake manifold off, you might be able to see visually if the ports are not clogged or anything like that. So EGR performance fault can be because of these ports are blocked. Okay, it can also be because the EGR valve itself, the valve itself is broken, or blocked, or anything like that. So there's many possibilities. So to do all that in this engine, intake manifold has to come out and everything. It's gonna take a lot of time, and it's gonna cost a lot of money. So usually a vacuum leak can also give you the same fault. So, and there's a very large vacuum leak there. So first thing, probably we'll just recommend customer to change that hose. To change that hose, we need to take the intake manifold off anyway, and then we can probably visually see the intake ports to see if these EGR ports are blocked or not at the same time. So we didn't do all this testing, but I can show you here and explain to you why having an intake manifold leak can give you an EGR fault. Okay, now I got a little chart up here, so we're just gonna focus on this, and I'll try and explain to you what I'm talking about. So we got a EGR monitoring system. So how does the EGR monitoring system works? How does the computer monitors the EGR function, and it knows when there is enough flow or insufficient flow to throw a fault code? So this might work for a lot of cars. Not all cars are done this way for EGR monitoring, but I've seen GM cars, a lot of GM cars, and definitely Ford cars, and some Mitsubishis also use this system to monitor EGR system. Now, I've got on this side EGR valve opening, and I got here intake manifold pressure. So usually this is done when the car is on deceleration mode. So coming back from the revs, going towards the idle, the EGR monitoring system usually check for the performance of the EGR system. Now, what happens is when the car is on deceleration mode, what happens is the EGR valve computer opens the EGR valve. This is just a random number I picked. I mean, it could be different numbers on different cars, but this is just the basic idea on how it works. Okay, so on a deceleration, EGR valve is open as one step at a time. So you'll open 14%, 15%, 16%, 17%, 18%, and go. You can go on from there. So when that EGR is opening, the computer is monitoring what's the intake manifold pressure doing. Now, this is just the basic signs when you introduce exhaust gas, which is pretty much, let's say, atmospheric pressure pretty much on the exhaust. When you introduce atmospheric pressure into the intake manifold, what's going to happen? The vacuum going to drop, as in the pressure in the intake manifold going to increase, right? So that's what computer is seeing. When it's open at 14%, let's say it's sitting at 4 psi, 15%, you'll jump up to 5%, and the pressure will increase as the percentage of EGR valve opening. Now, some cars I've seen, it can also do going down as well. So here the EGR valve opening percentage is going up and the intake pressure is going up at the same time. Now, after this sequence, the computer immediately lowers the value. So it's sitting at 19%. Let's say you'll start to drop the opening percentage 16, 15, 14 like that. So the percentage of EGR valve opening is dropping now, and it wants to see the intake pressure going down as the valve is closing. And when it's finished with this cycle, it completes the check, and if it's a pass, you will have no fault. But if it fails, you're going to have a fault code. Computer will throw a fault code saying EGR insufficient flow. So in our case, in this car having a intake manifold leak, this intake pressure is gonna mess up. The reading's not gonna be correct because we already have very high pressure to begin with, because intake pressure is leaking to the atmospheric. So that's why the computer thinks the EGR, because when the EGR is opening like this, the pressure doesn't change as computer wants to see. That's why it thinks the EGR valve is opening, but there's not enough flow of gas, because if the gas was flowing, intake pressure will change. Right. Okay, that's on monitoring system. Now let's talk about, alright, we talked about that, we talked about the valve. Let's just put that aside for a second. Now, a few other checks you can do on this EGR valve. I didn't do any of this test, but you can certainly do a test on this EGR valve. Now, this is a this EGR valve is a I'm trying to think of the name. The stepper motor type valve. So what that means is they got multiple circuits where the motor opens and closes in steps. Some throttle intake some idle control valve also use the same design. On this design, this is a stepper motor type EGR valve, right? So this one, you can't really check it that easily the way we wanna. We can check on a lot of different EGRs. A lot of the newer system EGRs, they only use power and earth, and you can see when they're opening, you pretty much work on duty cycle, and you can see that on scope. It's pretty easy to see when the computer is controlling the EGR or not. But on this design, you can't really check that as easily. There's definitely ways to check it, but definitely not easy to do that. And even to do a bidirectional, like manually putting power and earth into the EGR to open it or close it, you can't do that on this system. I've heard about something like you can definitely do it, but it's not as easy as just having two wires going into it. You can just put power and earth and it opens. I can discuss about that a little bit, how you can still do it, but before that we need to talk about the circuit diagram on this. So just go back here. So this is your EGR valve wiring diagram right here. This is your EGR valve. So it's got 6 pins on the connector, right? So 2 pins, 2 and 5, comes directly from the fuse. If you follow up there, fuse 10, fuse 35, 10 amps. Okay, so you need to see 2 power feed on ignition on all the time. Now this other 4 wires comes from the engine computer itself and controls this motor here, stepper motors. All right. Inside of the EGR valve, this is a proper wiring diagram, exhaust gas valve. So we just saw on that other wiring diagram, we have 2 powers coming in from the fuse, and we got 4 wires coming from the computer. So the computer grounds the circuit in a sequence. So here's a sequence of how it grounds it. So phase number 0, coil A is on, and coil B is off, coil C is off, and coil D is on. And sequence 2, and it just goes on. Different coils are opening at different times. So that's how it reaches its desired percentage of valve opening. And when you're closing the valve, it just does the same way, different coils energize at a time. So down here you can see open valve phase is 0, 1, 2, 3, and closed valve phase is 3, 2, 1, 0, 3. So it just reverse the process to close the valve. You can see here coil A, coil B, coil C, coil D. So we got 4 coils in that valve. Now what you can do is you can measure the resistance between each coil to see if the coils itself, the motor itself, are okay or not. Okay. Now to manually energize this, as in putting power and earth, you're going to have to follow this sequence, and you can open or close this valve. That's what I heard, that's what I read somewhere, but I haven't done it, so I'm not sure how difficult it's going to be, because to me it does looks very difficult. Because let's say on phase 0 you want to open the valve a little bit, so you're going to have to put earth on coil A. You're going to have to energize coil A and coil D at the same time, then still keeping the coil A energized, you're going to have to move the coil D earth to coil C, and keeping the coil C still on, you're going to have to energize the coil B and such. So you're going to have to do that like sequentially, and I found this, I think it's going to be really difficult to actually do it. But you can try it and tell me, comment on my YouTube, see how it go, see how hard or easy that was, but I've never done it myself. Here also I found a little, I think this is from a factory manual. I found a little information there. So it says up here, connecting battery voltage to the EGR valve for a long time could damage the coil. So not for a long period of time, just momentarily. It says connect positive of the battery to terminal number 2. So up here, if you look up here, number 2 and number 5 is our power source. It comes directly from the fuse. Okay, and this 1, 3, 4, 6 is our earth terminal coming from the computer. So I'll just go back here quickly. So if you look up here on this diagram, this is what you're going to see on the actual EGR valve. I think this is upside down, but you got the idea. So 1, 2, 3, 4, 5, 6. So this middle 2 pin up here is going to be your power feed, and this other 4 is your control circuit. Okay, and when you're checking the resistance, you just simply put your to check the resistance, your multimeter between the middle to the one of the other legs. And also at the bottom row, same thing, middle is a power supply, so from the middle to left or right, you can check resistance. Okay, we can talk about that in a minute, but let's just talk about this picture here, this information. It says terminal of the battery to number 2, so positive on number 2, and put negative on 1 and 3 pin at the same time. So it wants you to put power and earth on both 1 and 3 and power on number 2, and it says in order to test whether the stepper motor vibrates with a slight shudder. So if you feel a slight shudder when you do that, that means the valve motors are intact. And down here it's also give you information on the other 3 pins, 4, 5 and 6, but it's exactly same thing. Basically power on the number 5 pin, earth on 4 and 6, and you feel for a little vibration on that ECR valve. That way we know that it's doing something. Okay, now let's go back to this picture. So basically one more test we can do, I discussed earlier, is check the resistance. So you're going to have to check the resistance between that and that for that coil, between that and that for that coil, and so on this coil as well. So there is 4 coils in this ECR valve. Now let's go back here, and this one will give you sort of idea what you're looking for. Okay, number 2 and number 5 is obviously power, so you're going to see battery voltage. And number 1 and number 2 pin. Let me bring that picture back up quickly. Maybe here. This one. I'll just minimize that. Okay. Let's try that. Okay, so number 2 and number 5 is our power supply, the middle pins, and between number 5 and earth, between number 1 and 2, you're gonna see 13.4 ohm. Between 2 and 3, you're gonna see 13.7 ohm. Between 4 and 5, you're gonna see 13.6 ohm, and between 5 and 6, 13.7 ohm. So this is the 4 coils we're testing for resistance. Okay, let's go back here. See anything else I can talk about here? So, no, I think we covered pretty much everything. So basically, because of this stepper motor design, we can't really do a bypass test or manually energize this EGR valve in order for us to sort of check the flow of the exhaust gas or the operation of the motor itself. So this is just the information, see if this helps you guys out there. But like I said, sometimes just have to also consider how much money customer wants to spend, and you know how much testing you wanna do, because if I have to do all this testing on this engine, including taking the intake manifold valve to check these ports for blockades and all that, it's gonna be a little bit expensive. So we just left our diagnostic to the intake manifold vacuum leak on the PCV pipe, and I'm pretty confident that this was the problem, and this is going to fix this.